Namaste and good morning students. So today will be the first class of the second chapter, that is force and laws of motion, and I hope that you will enjoy this chapter as you have enjoyed the previous chapter, and you will take more interest in knowing this chapter and doing the problems and questions related to this chapter. So without making late, let's start. See, in previous class, what we read? We read the chapter motion, and we read regarding some of the concepts like speed, velocity, distance, displacement, acceleration, deceleration, retardation, all those things. Those things. Now, in this chapter, what we will be studying? In this chapter, we shall be studying what are the things that cause the change in speed, what are the things what cause the change in motion, what cause the change in displacement or distance of a body, or what cause the change in acceleration or the retardation of a body. So we shall be studying the cause of motion in this chapter. Today's class we shall be learning 3. If time permits, then we shall go further. So first I shall be giving you a little introduction about this chapter, and then we shall be knowing what is balanced force and what is unbalanced force and what is the difference between them. We shall know it by taking some examples also, and later on we will come to know about one of the 3 laws, that is first law of motion, and how this law came and what led to the foundation of this law and who gave this law, that we shall be discussing. So, before knowing what is there in this chapter, let us know that before all these laws that are known, which are regarding the laws of motion today, there were some concept which was accepted before none of these concepts, or before these laws came into existence, or before these laws were proposed. There were something which was accepted before these laws. So, what was these laws? Let us understand by taking an example. See, just imagine this is a ground, right? And here one football is there. So you kick the football in this direction. It is obvious that the football will come to rest after traveling a certain distance, right? Same thing also if we do, let's say you throw a stone in this direction, and the stone will not fly away. It will also come to rest after a certain time, after traveling a certain distance. The same thing happens to every object. So it was assumed that rest is the nature of every object. Every object tries to come to rest. But later on, this was proved that this is not the fact. Rest is not the nature. Rest is not the only nature. So then comes the laws of then comes the laws of motion. So, how this laws of motion come? Let us see. See, now we can understand it by taking the diagram which is given in your book, how Galileo gave some concept regarding this, and using those concepts, Sir Isaac Newton proposed the laws. So, what Galileo first observed, let us see. Let us say, this is an inclined surface of height h, and it is inclined at angle theta, let's say. Now, if a ball or a spherical substance is rolled on this inclined substance, and it is obvious that while coming down, its speed will be increasing, and here another inclined substance is kept of same height h and of same angle theta. Now, we observe what Galileo observed, that the ball velocity increases and reaches maximum till when it reaches the ground, and after that it goes on climbing the next inclined surface which is placed opposite to it, right? And its speed goes on decreasing and becomes at least 0 here, and then comes here. Now Galileo changed the apparatus. Now what he did, he removed this inclined substance and he put another one inclined substance whose height is same h, but its angle is not This angle is theta 1, let's say, and theta 1 is less than this theta. So he observed that the ball comes to the ground and later climbs this another inclined surface and climbs till its height reaches h. But he observed that here this distance s, if we assume this distance is s, this distance is more than s. Let's say it is s1. Here s1 is greater than s. Right. Now let us be made which and this substance also. He kept another one substance whose angle is theta 2. Right. Another one inclined substance whose angle is theta 2 of same height h. Now, what he observed? He observed that the ball will travel to the ground fast, and here its speed will be maximum, and then the ball will climb this inclined surface, and it will climb till its height reaches the height h. And he observed that this s1 is very less than this s2. If we say this path is s2, then this s1 is very less than s2, or we can say this s2 is greater than s1 and greater than s. So what we come to know here, that can be explained by knowing the first law of motion. Observing all this phenomena, Isaac Newton gave the concept or gave the law of first law. Now another one set up we can take. Now just imagine the ball is made to roll down, and here no inclined surface is there. So the ball will go on traveling infinitely till it reaches the height h. Otherwise it won't stop. So in all these three cases we have ignored the frictional force, we have ignored the air resistance. If frictional force and air resistance would not have been present, then this would have happened definitely. So what explains these properties of the motion? That can be known from the first law of motion. So when we shall be studying the first law of motion, we shall be knowing what made the ball to reach to the same height until it reaches the same height h, it goes on traveling. What makes the balls to go on like that? So now balance and unbalanced force. See, the definition of balanced force is like that. The resultant force acting on an object is said to be balanced if the resultant force acting on an object is zero. Let's say here the book is at rest. What are the forces acting on book here? Gravity, downward, and normal reaction upward. Normal reaction upward. Here as the book is not moving either downward or upward, it just means that the normal reaction and the gravity are same or balanced to each other, or the resultant force acting in this case is zero. So in this case it will be a balanced force. The force given by the gravity is balanced by the normal reaction of the book. Right. Now let us take another one case. You can see the diagram given in your book, in which three cases are given. In which two students used to push a block of wood. Right. Let's say this is a block of wood. You are pushing this block of wood. Right. Pushing in this direction. At first you are pushing it very slow. Now it won't move because the amount of force you apply in this direction will be balanced by the amount of frictional force which acts on opposite direction. Now you and your friend both see, in first case what you did, you pushed the wooden block and you pushed, but you could not make the wooden block to come to a motion from rest to motion. opposite direction. But in the second case, you asked your friend to help you to move this wooden block. So both of you pushed the block with huge amount of force, and you could overcome the frictional force which acts in the opposite direction, and as a result of which this wooden block moved. So now let us understand what is the difference in these two cases. See here, what much amount of force you have applied, that much amount of force friction is applied, or we can say that your force is balanced by the frictional force in this case. But in this case, your force is not balanced by the frictional force. As a result of which, your force you could make this object to be in motion. So in short, we can say the resultant force acting on a body will be zero in case of a balanced force, and the resultant force or the sum of all the resultant force acting on a body will not be zero if it is unbalanced force. So if a body moves or if any change in position occurs in a body, it just means that there must be some unbalanced force acting on the body. First law of motion. First law of motion is based on the idea given by Galileo, and it was proposed by Sir Isaac Newton. Sir Isaac Newton studied the things or studied the concept given by Galileo regarding motion, and then he gave 3 laws of motion. And we shall be discussing first law of motion in detail in this class, and we shall be discussing it in more detail in next class. See, first law of motion states that a body at rest will try to retain its position of rest, or a body in motion will try to retain the position of motion, unless and until an external force is acted upon them. Now let